So many years ago, probably 30, 40 years ago, there was a British comedy troupe called Monty Python and Monty Python's Flying Circus. And they had this transition whenever they would do a skit, and it had nothing to do with what they had done before. In the earlier skit, they would say, and now for something completely different. And so that's what we're about to do. We're now going to start talking about something that is, at least first glance, appears completely different. And we're going to start by talking about Spring and Spring Boot. And these are essentially environments for programming production-grade web applications using all kinds of interesting patterns and techniques that we're going to go into in some detail. And this is relevant because, even though it's completely different, it's relevant because your next programming assignment will have you doing this, because we're going to have a client-server architecture that will replace our entirely client-driven approach that we've used up to this point. So we're going to give an overview about what Spring and Spring Boot are, and then we're also going to talk about some of the key components in Spring Boot, and you'll get a chance to implement a bunch of this stuff as we go through the next assignment. So what is Spring? Spring is not just a season of the year, but it's a dependency injection framework and a so-called inversion of control container for developing production-grade web apps using Java. There's a whole bunch of other stuff that Spring is as well, but that's what we're going to be focusing on here. So what is dependency injection? Dependency injection, or DI, enables an object or a service to receive other objects or services that it depends on. And what it does is it enables the auto-wiring of these dependencies in lieu of manual wiring. What the heck does that mean? Well, usually when you write programs in more traditional style, you'll end up doing things like, object foo equal new object something or other, right? You'll make a new, not object, but a class of some kind. And you do that wiring explicitly. And that's certainly a time-honored way of doing things, but that's been discouraged over time and replaced with other techniques like factory methods, where you don't have to reveal the lexical dependency on specific classes. You can abstract away from that. And so auto-wiring is kind of the same idea, just taken to the next level. And so you have some service, and you have some client that needs to use some service, and the injector will come along and auto-wire or connect those things together automagically. And you can read more here in this article about auto-wiring with Spring. Spring is not the only thing that does it like this. Dependency injection is a common technique that's used in other frameworks as well. Inversion of control is a way of structuring your code such that the framework, the infrastructure, the piece you get off the shelf, runs the main execution thread or execution threads. So rather than you controlling the path through the application's control flow, the framework does that for you. And this is usually done through something called a callback, or callback techniques, or hook methods. And we often refer of inversion control as the so-called Hollywood principle. The late, great John Blasides wrote a funny article about the Hollywood principle. And the Hollywood principle is about, don't call us, we'll call you. And so that's the whole philosophy behind inversion of control. You register your objects with the framework, or objects are created for you by dependency injection, and then those objects are called back. Methods on those objects are called back at the appropriate time by the framework when control is necessary to get to that point. There's a whole bunch of various projects that are part of Spring. There's cloud stuff and security stuff and data-related stuff. We're going to focus on Spring Boot, which has two key parts. And we're going to be focusing today and for the next week or so on the so-called servlet stack portion, which is sometimes referred to as Spring Web MVC for Model View Controller. And as we'll see, that's a synchronous programming model. And then later in the course, after we've had a chance to talk about reactive programming, we're going to talk about Spring Web Flux, which is a reactive stack which deals with things asynchronously. But we're going to do this one step at a time. So let's talk briefly about some of the key components that Spring provides. So the purpose of Spring, again, just to reiterate, is to make it easy to create standalone, production-grade web applications, web-based applications. The kind of thing that people use all the time. Almost anything you do nowadays with your mobile device or your browser or whatnot is talking to a back end, and Spring is used in a lot of those. And there's a couple of different components, and they interact in interesting ways. If we start at the left-hand side of the slide, the first thing we see here is the client, which could be a browser, it could be a mobile device running a native app, it could be a standalone app, it could be a console-based client, it could be all kinds of stuff. The point is it's going to be sending requests to one or more servers. And those requests, as you can see here, are going to be generated under the hood using HTTP. You undoubtedly know what HTTP is. HTTP is an acronym that stands for the Hypertext Transfer Protocol, and it's a request-response protocol that's used in a client-server computing model. So you have a client, sends a request, the server processes the request, sends a response back, request-response. And no surprise, there's an HTTP request type, there's an HTTP response type, there's headers, there's bodies, there's all kinds of interesting things. And we'll talk in more detail about how this works. And ultimately, it typically is used with something called a RESTful API, which stands for Representational State Transfer. And that sends requests in things like a GET request or a POST request or a DELETE request and so on. And we'll see more about that. Basically, think about it as URL-like ways of identifying where to send the data and what information to be passed. When the information goes from the client to the server, it's handled by something called a controller. And we'll talk more about controllers. You'll get a chance to play with controllers. They're very important in this model. And the controller's purpose in life is to map these incoming HTTP requests to so-called endpoint methods or endpoint handler methods that handle these requests. So the requests come in as HTTP, and then the controller and some other parts of Spring Boot are responsible for converting those requests into method calls on objects that are the controller. And there's all kinds of cool magic that takes place to make that happen. And the controller can do various things, but most commonly, and certainly from my style, it doesn't really do a lot of business logic. Instead, it forwards the incoming request, which has now been turned into a method with nice Java native types or reference types. It then turns around and forwards the request using the Java type system to a service layer. And that provides the so-called business logic that operates on the data that's sent from the client. And it will then typically turn around and will go ahead and do some other back-end processing. By the way, controllers and services can be connected using dependency injection so that typically the way in which the wiring is done is handled automatically. So the controller is connected to the appropriate service without you having to write the constructor or factor method code to do that directly. The service layer typically interacts, not always, but typically interacts with some persistent data. And this is what's typically called the model layer. And so it's a data model. And oftentimes there's different ways to do this, but the most common way to do this with Java is to use the so-called Java persistence architecture, the JPA, and that can also be automated largely. So you don't have to write a lot of database operations. Those are done for you using the magic of reflection, which is one of the powerful features in Java. And so once the model and the persistent data is accessed by the server, then other things will happen, and eventually there'll be a response that goes back to the client. The interactions that occur from the controller to the service layer to the model are all typically just good old Java calls. Now, we'll see later that you can have a microservice architecture where controllers can talk to other controllers that may reside elsewhere. But for right now, let's just keep it simple and pretend like we have a monolithic application where the requests are all handled in one process. So that's the end of the overview of Spring and Spring Boot. We will look at some other presentations and lessons here shortly that will dive into each of those parts in more detail.